So hi. So my name is Setu. Today I'm just going to tell you about what is time complexity. So this video I'm just shooting for myself only. That I just wanted to keep a track that how my DSA journey is going to start from today till 3 months from today's date. Okay, so today is the first topic, and I learned about time bound complexity. Let's suppose there are few programs to tackle one single problem. Okay, so how you gonna judge that which piece of code is efficient or which code of piece of code I should use it? Okay, so there comes this time complexity things. So this is the graph as you can see. Okay, so let's suppose there is one example like you have nine different balls, nine balls, 8 out of 9 are same and one is the little bit heavier but size is the same. Okay, so how you gonna decide that which one is the odd one out? So there is one case that you go with for loop, check the weight. If it's above certain threshold, consider that it's the odd one out. This is the first one. But for doing these things, we need to iterate 9 times or at most 8 times. Not nine times, but 8 times. So it's kind of uh, okay. Okay. Now, is there any another approach where we can uh, find out the odd one out with very efficient and with less time? Okay, so another approach is that let's make one array. Okay, in whatever Python language you programming language you choose, uh, make one array of containing 9 elements and put the weight of everyone. Okay, every each and every board. So after that, yeah, make a pair of three. Okay, first three, second, third, and last three. Okay, make a group of A, B, and C. Let's suppose apply one for loop, if loop, if condition. If A is equal to B, means A is the sum of the first three balls, weight of the first three balls. B is the second, uh, fourth, fifth, and sixth weight of this fourth, fifth, and sixth, and last C is the weight summation of the weight of 7, 8, and 9. Okay, so if A is equal to B, then C has, then B has odd one out. Now this is the one if condition, three if conditions in the first condition, first statement. After that, in every if condition, we need to write again two if condition. Let's suppose one if condition again. Okay, now out of three in A, B, or C, whatever we find out. Okay, if A is equal to B, sorry, 1 is equal to 2, then 3 is the odd one out. If A is greater than 2, then sorry, my bad. If 1 is greater than 2, means 1 is the odd one out. If 1 is less than 2, then 2 is the odd one out. And how this is how the simple it is that we can able to find the odd one out within just a two comparison, just only two. The piece of code will be very much longer because this contains lot of code, but it is very less time consuming because we are just using two conditions in this piece of code. But while in the case one where we are using for loop, at that time we need to use a eight comparison. Okay, which is makes our code little bit more uh, uh, time consuming. So even if that first code has a 3 or 4 lines of code, but it's very much time complex, and rather than over here in case 2, piece of code will be around 20 to 25 lines, but it's very much simple. Okay, so to justify or to identify those complexity, we can use as you can see in the screen that this is the chart that how time complexity has different functions based on its input parameter, and it's basically depends on the input size. Okay, if I'll put a large amount of data, okay, 1 lakh variable, then it's obvious that it will take some time. But if I'll just give a two variables, it will going to solve that problem within just 2 seconds or very much less time. So this is how this time complexity looks. As you can see, for good algorithms, even if you give the input size higher, it will take lesser time. If you in the for the average, it's kind of average, name suggests that. And in case of bad algorithm, okay, even if you give uh, lower input size, they're still going to take much more time. Okay, so yeah, And one more thing, this big O notation, as you can see over here, right? So it's kind of a notation to describe the time complexity in three different cases. First one is the omega, second one is the theta, and third one is the big O notation. The omega means that best scenario. Okay, let's suppose I am using best computer, I am having it, and I am running that computer while I am using that software while no other softwares are running on my PC. So at that time it will definitely going to give me a best results. Okay, so it can consider as a omega, best case. In the second one, let's suppose some other apps are using it, I'm using on that same PC and still running my software. Okay, it will take some time, so it's you can consider as a average case. And in case of third one, let's suppose whatever condition, how bad it is, this is the worst case that I'm getting it. So this O denotes for a worst condition, that above, it can take, let's suppose my program is running for 60 seconds, and that's the worst case. Okay, so if someone asks that what's the time complexity, I can say that it will take a 60 seconds for sure. Less than that can be possible, but not more than that. So this is big O notation to describe the worst condition. Okay, I hope I make sense. See you soon for the next lecture. Yeah, bye bye. That's all for now.